Hello, I am Farrukh Nadeem. Today, with a new tutorial, we will adjust the bitmap, correct its brightness, fix its contrast, and then we will trace the bitmap. There are two methods for tracing. One is for color and the other is for black and white. Let's start the exercise. Here I take a file of 24 inches by 24 inches and I selected the center base. And here we have the area of 2 by 2 board and I will import it. For a bitmap image, I need to go to my root. I select such an image, and as soon as it comes here, I will need to crop my desired area. Otherwise, in tracing, this blue strip that is coming down, it will also appear, so I will need to take a rectangle. Using the rectangle command, I took a rectangle and selected the area I want to crop. You need to select both the bitmap and this object and then crop from here. As soon as you crop, remove the rectangle and the image you have is now available to you. Scale it. Enlarge it to the size you want it to be. It's generally better to maximize the size for better accuracy. But keep in mind for bitmap tracing that the quality of your bitmap image should be relatively good. Try to have it in separate colors. The colors should be clearly visible here. You can see that there are watermarks on this image. So to adjust these watermarks, I first need to go to the Open Picture Editor. As soon as you open the picture data, you have three options here: contrast, brightness, and gamma. Here you can slightly change its contrast. Contrast basically, enhances the colors, meaning if it's black, it will make it a darker black, and if it's white, it will make it even whiter. Similarly, if there is any other color, it makes each color the most prominent. Brightness adds a bit of shine to it. When I slightly reduced its brightness, you saw that its watermark was removed. In a similar manner, you should consider utilizing a small amount of gamma correction. This adjustment is particularly useful for fine-tuning the image by addressing and modifying the remaining watermarks that were previously visible. By applying this technique, you can effectively enhance the image quality. Once the gamma correction is applied, you can proceed smoothly and effortlessly through the editing process. As a result, we now have this image available in its improved form. To elaborate further, gamma correction is a nonlinear operation used to encode and decode luminance or tristimulus values in video or still image systems. It is a crucial step in the image processing workflow, especially when dealing with images that have varying levels of brightness and contrast. By adjusting the gamma, you can ensure that the image appears more natural and visually appealing. This process involves a careful balance of light and dark areas, allowing for a more accurate representation of the original scene. With the gamma correction applied, the image is now ready for further use or distribution, having been refined to meet the desired visual standards. My recommendation to my colleagues is that technically, when you are designing, try to trace it with geometry. If you trace from bitmap, there were numerous corners that would be rounded off. As you can see here, these corners have disappeared like this, and see Remus. The corner round is coming, and from here it is not as flat as it should be. There's also a slight curve coming in here. It is somewhat flat, but the sides here do not have the proper curve. You might remember in our previous lectures, I taught you how to trace this same image, right, and create it with geometry. So I personally always recommend that you definitely use tracing as a support, but draw your own geometry over it. Similarly, whenever we or do any work, we need to see where its requirement is and what kind it is. For instance, if I go back to the bitmap and trace it again, you can see I've given its preview in black and white. Apply it and then cruise, and you will have the lines available. I turned off the bitmap layer, and now I have the vector available. All right, we were discussing that I recommend you design according to your requirements. If you are not going to place this design on a very prominent place, or if you just need to make a cutting or pocket where high precision is not required, then it's okay, it will work. However, if you need more precision and want to place it in a more prominent location, I would recommend improving its accuracy and drawing it geometrically. So viewers, once we have traced this image, we have its vector file available. You can see that the vector file is already made in group form. Here I will switch it to the toolpath. Once switched to the toolpath, we have some features here, like you saw the XY datum puts on. It has marked the XY datum in the middle. These are some settings where it shows the clearance of the jig, the thickness of the job, and the position of the jig, and you can adjust it from here. So let's move to our desired target. We have toolpath operations available here, and first we have its profile. There is a toolpath followed by a pocket toolpath, drilling, and similarly the remaining toolpaths are also available. So here, the one I want to work on today is the pocket toolpath. As these are pocket tool paths, within the pocket tool path, the first thing is where you want to start it from. I want to start it from 0. This is normally used when you are extracting another within a pocket. At that time, the start depth is used. But for now, since we are cutting the top surface correctly, so the top surface is 0. And after that, I have given its cutting depth. It is 0.25. And for the end mill, which one you have to take here, remember that for this kind of work, use an end mill. It goes. And the middle cutter here is taken as 0.25, as you can see here, and all its values are present. Actually, approve them, edit the pass, open the passes we have here. Basically, what are passes? They are the steps in which you will cut the job card with a thickness of 0.25, and each step is called a pass. I want to do it in one pass here because we are generally using soft materials like MDF or softwood. However, when working with blackwood or slightly harder materials, we need to use multiple passes. So I did it here with a single pass. It showed you 2 positions, offset and raster. You can see from this preview how the cutting will be. After that, I calculated it without a pocket profile. This file is showing you a tool path here. Yeah. Preview it from here. You saw the cutting car's preview. Slow down the speed, reset the preview. Yeah. If you preview it, you can see this is how the cutting is done. Or if I cancel it and go back for editing, you can use the path here and calculate. The file has changed and it designed the pass like this. I reset the preview and preview again. So now the cutting style will be like this. So it depends on you how you want to do the cutting and how you want to use the tool. Close it and come out. Here we have the option to save the tool path. Click on the tool path you want to save and go to Save Tool Path. From here, select the post processor for your machine and save the tool path. For the tool path, I used the desktop. I generated a file named Pocket1. Cleaned the vectors we had using the Pocket tool path. Similarly, for our next exercise, we will go to New. Here, I will create the size of a door. Let's take a door with a width of 2 feet and a height of 6 feet. I have given this point and then click OK. I have a bitmap available for this. I will go to this bitmap, and as soon as I place it here, I will illuminate the bitmap. I will tell you. Again here, you must definitely keep its scale large. So along with increasing the scale, you will have to crop this image. The method for cropping the image is already available to you. Take a rectangle from here and place it from this point to that point to take the rectangle. Now zoom in a little so that you can get an idea. See what you need to create. It shouldn't touch from this side. It shouldn't touch from that side. And it shouldn't touch from this side either. What is the reason for this? Because if we include this area, tracing will also occur over it. Since we are currently doing all this work as tracing, I have selected both this and the image. Look, I have taken both objects in the window and trimmed them, so the designs you have which you want to trim, first give this design a margin from here so that it becomes easier for you to work. Offset it 5 inches inside, Paul. As soon as I offset it by 5 inches, notice that the size we have now has changed from 30 to 20 and from 72 to 62. Where can we check from? Now check here as well. The size has come to 62 here. Well, this is your margin. If you want to adjust it manually, but if I don't want to adjust it manually, then select this image. Go to Scale. Unlink it from one side and set it to 20 from here, and from there, unlink it and set it to 62 from there. Apply it and it will adjust the size. Or align it. Aligned in the material, it automatically aligns with its correct size approximately. Here I have set this up. The very first task is to go to Edit Bitmap Panic. How will you go to Edit Bitmap? And here, slightly improve the brightness and adjust the contrast a bit. Look at this. And in this way, when I adjusted the brightness, it switched. So 2 colors. Okay, one way is to do it directly through this editor here. And if you want to use the output CSS, I closed it and went directly to trace. As soon as you select this image, go to trace and set it to color, and see here, it has given 16 colors which are naturally marked in it. You need to gradually bring it down to 2 colors. when you bring it to two colors. Which color do you want to select? In brown or off-white? Okay, actually when it traces, it will trace those same things. I mean, suppose I now say brown, and then it has to pick the brown color, set its range to medium from here, and apply it. So you see here, I closed it, and the tracing is done. Turn off the bitmap layer, Alt-Sum, and see it has traced it here because it's all grouped. Ungroup them, and from here I need to fix these additional objects that have been added inside. How will I fix them? Take the pointer, node, and cut the vector. Also take node here and cut the vector. In this way, as soon as you go to the selection tool, this object becomes separate. Now, with the help of the node, you can edit it. I placed it here and aligned it with this and removed the extra nodes from it. See, I also removed the extra ones from here. And with the help of these anchors, you can adjust its curvature. See, the curvature has been adjusted. Similarly, if you feel like you want to make some settings here, by pointing, I will insert a point here. And if I delete it, the curve will automatically adjust for you. See, I am moving it slightly upwards. Remove this as well by deleting the point and improve its depth. So viewers, in this way, we fixed the geometry that was a bit disturbed, and you have this trace geometry available. Group it with Ctrl G and resize it as we did before. I applied the base and 62 from here, then closed it. Again, align it with the material. Once you align it, the object is ready for you. Now we need to cut this object as well. Consider it basically a door. Think of it as a ventilator or a window. We need to cut this door through the material we created. I switched to the toolpath, and as soon as you come to the toolpath, we have the toolpath available here. Use the profile tool for toolpath cutting, and from here you will mark its cutting. Since we have used a material of 0.75 and are also doing the cutting depth at 0.75 so that it can be cut through, you need to select the tool for cutting. For example, here we have started with the 0.25 tool. Select that tool accordingly. Edit passes, and you're allowed to, I have briefly explained this before as well, that these are its steps, how many steps it will take to cut. Since we have soft material, it's dirty. I want to cut it in 2 steps. See, I have given it 2 passes. It will cut in 2 steps. And where should the cutting be done? From inside to outside. If done outside, the outer size will be disturbed. If done inside, the inner will be disturbed. If the inner gets disturbed, that's fine, because we need the outer part. We have to remove the material from the inside, so I will cut on this side. And when you come to the selector, it will give you some features here, like here it is. In the section, you have an object whose operation time is 40, and there is no operation time. If there was any operation time, it would have been shown wherever it was being displayed. So when we come to the selection filter, it says here which operation time you want to work on, open or close. Currently, we don't have an open operation time, so what will we do? We will keep selecting the close operation time. It also includes a circle, rent 1. Collect. Circle 360. When the manager selected this, he also provided a layer here. So I tell him to cut on layer 1, close it. Your selection will be made, calculate it. As you calculate it, notice the double path. It created 1 layer above and 1 below. These are basically the cutting paths according to which your tool will cut. Come to the preview here. When I looked in the preview, see how it will cut each object twice. If you want to preview it properly, double-click on the declaration you want to remove and view. I have to remove and view this declaration. Look, viewers, the declaration that needed to be removed has been removed in front of you. This is what we will get on edits after cutting. Now that we are here, we will discuss a couple more things regarding cutting. I will close this. Here we have the create a job sheet. You create a job sheet here. I place it on the desktop. This is its new summary. I created the job sheet. As soon as you create the job sheet here, you will go to the desktop and a file with the name of the new summary has been created. As soon as I open it, it sets the complete details on a paper for us. First, it made the job setup sheet, job layout material. Look here, its preview is visible. Similarly, it has given its size and all its positions have been mentioned. This sheet is actually made so that when you complete the programming and send it to your operator, the operator will prepare the job by following these things as mentioned here in the material setup. It is a material of 30 inches by 72 inches with a thickness of 0.75. The start position is 00, which is at this corner. The datum position for Z is mentioned here, and the XY bottom left corner is specified. Similarly, the clearance is specified here just as it is mentioned here. Tell its start position, and here it has given its clearance. What is the summary of this toolpath? Profile 1 needs to be cut. The end mill cutter is installed and the estimated time is 34 minutes and 50 seconds. This is the time it will take. If we go into the toolpath profile, it tells us in the toolpath info that a 2D profile toolpath is being used. The feed rate is 100 inches per inch. The plunge rate is 30 inches per minute. The estimated time has been provided and the spindle speed has been mentioned. Here in the tool info, it is mentioned that an end mill tool will be used, which is 0.25 inches. The tool type is an end mill and the maximum cut depth is 0.75. The pass depth is 0.125. But since we have changed it, the feed inside it is 0.125. One tool will be used in the number of tools and the step over is 0.1. So this is basically the summary that it has created here, which we will need to give to our operator. Let's return to the software. Similarly, if you just want to see the time, you can look at the toolpath summary here, and it has provided the time. Close this data. And similarly, this is for viewing the preview, which we saw a little while ago. If you preview it, it will show the preview of this job. The rest of the things are a bit advanced. We will, God willing, cover those in the next lectures. Here, you need to set the save toolpath, which I have already mentioned. I will also briefly explain a few things about the save toolpath here. This is the post processor. Post processor is basically the processor that is being used in your machine. And from here, this post processor generates programs according to this processor. Therefore, you need to specify the processor here, indicating which machine you are using and which processor is being used in it. So from here, you will select the processor and it will work accordingly. Normally in our region, the machines that are operational use NC codes and it will work according to that in our region. In that, Mark III is used. Similarly, different branded machines have different post processors installed in them. So if you want to work on Mark III, look here, you will find different versions of Mark. You can select any version of Mark from here. If you want to work on NStudio, look here. Here are different versions of University Studio available. You can use whichever version you need. For example, I worked in Studio inches. So I used this inch post and saved it as a toolpath named Profile 1 on the desktop. So viewers, if we want to work on its programming file, like I double clicked on it, it uses both G code and M code. Look here, M code. M codes are basically miscellaneous codes. G codes are geometry codes. So the geometry is written through G code and the miscellaneous machine operation is created through M code. So it automatically wrote a complete summary that will help in programming. When you need to give data to your operator, you have to give them the summary sheet I created and the patent G code file. This is all they will need to do the work. You don't need to provide them with software or any other software. You just need to give these two files. One is the general summary, which will basically be the information, immediate information according to the job, and the other is the NC file. I hope today's lecture is adding something more to your professional life. Please subscribe to our channel for the next lecture. Be sure to share it with your friends and bless us with your valuable feedback through the comment box. Thank you very much.